Dear students, last week we discussed the spraying and investing of removable bashar denture wax pattern. Now we should know what the types of the metal that we should use for removable bashar denture. So we can discuss later on next week the burnout and the casting procedure to create a metal framework. The CAST framework offers significant advantages over the all acrylic resin removable bashar denture. In general, the ability of predictable utilizing the remaining teeth for support, stability, and rotation over time is best assured with the interface between prosthesis and teeth consists of a cast structure and not a polymer, which is not a polymer. Now, the alloys. The alloy is a combination of two or more metals. Most of the metallic material used in the dentistry are alloy because, in general, the pure metal is not sufficiently strong to withstand the force applied to it in the mouth. So the alloy is a combination of two or more metals to create a material which can withstand most of the forces applied in the mouth. The general requirements of casting alloy are, first of all, they must not tarnish and corrode in the mouth. They should be light in weight. The lighter weight aids in retention in the mouth, of course. Then must be sufficiently strong and high stiffness for the intended purpose. For example, using a brush to clean it or using any object, hard object against it. Now, it should be biocompatible as well, non-toxic and non-allergic. The metal do not exert elements which make a toxicity to the soft tissue or can make an allergic to the soft tissue. Should also economically easy to melt, cast, cut, grind it, easy to fabricate, as the difficulties in manipulation make the technician or the practitioner to use such a metal is difficult to be constructed. Now, it must be flow well and duplicate fine details during casting. So the metal should be smoothly melt and do not produce any defect after casting. Also must have a minimum shrinkage on cooling after casting, otherwise the dimensional accuracy will affect it, and this will affect later on the design and the fitting of the design inside the patient mouth. Should have also good fatigue resistance. This property is important for clasps, of course, because of the clasp with the short cross section or small cross section. Clasps have to flex when inserted or moved from the mouth. So beside the stiffness of the material should be flex as well, but not highly flexible material. If they do not, actually this may affect the design or maybe lead to fracture later on. Also have a good fatigue resistance. As they may break after repeat insertion and removal. So the material should be fatigue resistance for up to 3 or 5 years, of course. And this related to the many mechanical properties have been tested, such alloy in different cross sections before purchased or launched in the market. Uh, Now, the classification of alloy according to nobility. There are many classifications regarding the alloys used generally in dentistry and particularly in removable partial dentures. So, according to American Dental Association, the classification were according to the nobility of the material of the alloy. For example, we have high noble metal alloy, which mostly contain 40% by weight gold and 60% noble metals like palladium, platinum, and other components. The second classification were the noble metal, which does contain 25% by weight of noble metal element, which is not necessarily gold. That means it could be palladium or platinum, for example. And then the rest is for the other metals. And the most commonly used is the base metal alloy, which contain 25% of noble metal elements, and then the others with the probably other metals, which they are considered as a base metal. Generally, the type of the alloys used for removable partial denture framework, it's either cobalt chromium, gold alloy, titanium or alloy, and nickel chromium. And we will discuss this briefly in term of the properties of such a material and the characteristics of such alloy. Now, practically all cast framework for removable partial denture are made from chromium cobalt or cobalt chromium. So if we said cobalt chromium, that means the higher percentage going to the cobalt than the chromium. But if we notice that there is a chromium cobalt, or whether they are cobalt chromium, so the first named metal is to the highest percentage. Okay. Now, the popularity of chromium cobalt alloy has been attributed because of many factors. For example, the low density in weight, that's mean light in weight, high modulus of elasticity, the stiffness of the material withstand the force of insertion, removal, and term of clasp, the tendency of clasp to fracture up to 3 or 5 years probably. Low material cost, the cost of the material reasonable for the patient and resistant to tarnish. Of course, the material withstand tarnishing. The composition, generally the composition of the cobalt chromium or chromium cobalt related to the also the companies and the way that produce such alloy, whether they are using different systems in melting these alloys or combining the percentage in terms of the quality of the metal as well. So generally the cobalt composition 35 to 65%, and it's produce hardness, strength, and rigidity to the alloy. It has a high melting point. That's give the stiffness for the material. Now, the chromium is between 23 to 30%. The chromium content is directly proportional to the tarnish. So the cobalt for the hardness and the rigidity, and the chromium for the tarnish and corrosion resistance, which reduces the melting point. We also want to manipulate such alloy in terms of proper timing for the technician to deal with the alloys. Now, the nickel between 0 to 20%, the presence of the nickel metal increase the ductility, so we can manipulate that means it's easy to be finished or polished. And the molybdenum, which is between 0 to 7%, and this effective the hardness, it refines the grain structure. That means giving the alloy a fine texture. and the iron between 0 to 5%, which affect the hardness as well, and the carbon up to 0.4%. The small amount may have a pronounced effect on the strength. You know that the carbon affect the hardness and ductility. Carbon forms carbides with the metallic constituents, which is an important factor in strengthening the alloy. However, excess carbon increases brittleness of the material. And that's why we noticed most of the technician, when they burning or melting the over heating the cobalt chromium or chromium cobalt alloy, this will create carbon, which later on affect the final product by finding a propagation of fractures. This lead to increase the carbon within the alloy itself. But with the proper amount of 0.4%, this will control the alloy, the ductility of the alloy. Tungsten, manganese, and silicon, primarily oxide, scavengers to prevent oxidation of other elements during melting. They are also as a hardener. Whether they are hardener or scavenger, scavenger is the absorbance of the oxides away from the surface of the framework, which this control the oxide layer on the final surface of the framework, metal framework. And the beryllium, which reduces fusion temperature and refine grain structure as well. Going from the chromium cobalt alloy, which is the base metal alloy, to the gold alloy. The gold alloy contain more than 40% of gold, and therefore also referred to gold alloy or gold base alloy. The properties of such a alloy is high yield strength and low modulus of elasticity, produce greater flexibility in many instances. So the framework with such alloy, we should expect that the flexibility of the clasp may lead to affect the rotation later on because of the flexibility. But sometimes we need this flexibility, especially with the RBI, gingival approach clasps. This produces a distinct advantage in the optimum location of retentive element of the framework. The greater flexibility of the gold alloy usually permits location of the tip of retainer arms in the gingival third of the abutment tooth. Of course, it provides good castability, good tarnish resistance, because this is one of the noble alloys, and corrosion resistance, and low melting point. So if we need, for example, to add a class for the framework, we can use this alloy in terms of low melting point than the original framework. The other alloy that we may use with titanium alloy, and this alloy we can cast it or we can, for example, mill it. Nowadays we have the milling machines which can produce a framework without casting it, but also we can cast titanium alloy. Commercially pure titanium and titanium alloys containing aluminum and vanadium or palladium should be considered potential future material for movable partial denture. This is used for small thin structures such as clasp assemblies and major and minor connectors. Such alloy are the same as that of a typical cobalt chromium alloy, but with far superior ductility. It has been excellent biocompatibility, of course, because the titanium considered as a biocompatible material, light in weight and good in strength as well. And the last alloy to be used for removable partial denture is the nickel chromium alloy, basic element nickel, which is 61 or to 81% by weight, and the chrome, which is between 11 to 27%. Now, the properties of such alloy is this alloy tend to be harder, unlike the gold alloys. These alloys are extremely difficult to work with. Their high hardness makes them very difficult to cut. For example, sprue cutting, grinding, and polishing. So the manipulation will be difficult or it takes time and skills to be achieved. And these alloys are highly resistant to tarnish and corrosion, and it produces allergic reaction in some individuals. So that's that's why we have different alloys to be used in removable partial denture. Many patients may have a cobalt sensitivity or chromium sensitivity, so we can use titanium. In terms of highly costly titanium, there is a nickel chromium. The nickel, if the patient have a nickel sensitivity, we can substitute it all as an alternative, the chromium cobalt alloy, to be put in our minds. Now, the comparable characteristics of gold alloy and chromium cobalt, of course, generally each is well tolerated by the oral tissue. So, if we want to compare between them, it depends on the occasion and the patient whether they prefer it or not. So, this depends on the patient, of course. Uh, they are equally acceptable aesthetically. The enamel abrasion by either alloy is insignificant on vertical tooth surface, and the low fusion chrome cobalt alloy or gold alloy can be cast to wrought wire, and wrought wire components may be soldered to either gold or chrome cobalt alloy. These characteristics are important in overcoming the objection by some dentists to the increasing stiffness of chromium cobalt alloys for the position of direct retainer that must engage an undercut of the abutment tooth. And as I mentioned previously, we can use the gold alloy as repairable alloy for cobalt chromium because of the melting point. And this is the point of it, of having different alloys and different melting points. So the properties affect the use as well, or it's easy for us to select. The accuracy obtainable in casting either alloys, that means the gold or the cobalt chromium, is clinically acceptable under strictly controlled investing and casting procedure, of course. The soldering procedure for the repair of framework can be performed on each alloy. So if we want to repair any framework, so we can create a refractory material around the part that we would like to solder it, and then it's easy to be added the casting in terms of cobalt chromium or gold alloy. Now, in terms of, we have the physical properties, the comparable physical properties between the gold and the chromium alloy. Chromium cobalt alloy generally have less yield strength when compared with gold alloy used for removable partial denture. Now, the yield strength is the greatest amount of stress an alloy will withstand and still retain to its original shape in weak condition. That means it's like the spring back ability of the material under load and release. The gold alloy have modulus of elasticity approximately one half that for chromium cobalt alloy for similar use. That means if we use, for example, 0.8 gold alloy thickness for removable partial denture framework, this will be the load the elasticity of it's one half that of the cobalt to chromium. The greater stiffness of chromium cobalt alloy is advantageous, but at the same time offer disadvantage. Greater rigidity for can be obtained with the chromium cobalt alloy in reduced section, in which cross arch stabilizing is required. So eliminating an eliminating the bulk that we do not need of the framework, it is essential now. Its greater rigidity is also an advantageous. When the greatest undercut that can be found on an abutment in the nature of, for example, point 0.5 inch. That's mean we need the stiffness material to withstand the force of insertion and removal. High yield strength and low modulus of elasticity produce greater flexibility. The gold alloy are approximately twice as flexible as the chromium. That means the cross section. For example, the clasp of cross section made from gold and made from cobalt to chromium. The flexibility of that with the gold is higher than that with the chromium, cobalt to chromium. Okay, this provides distinct advantages in the optimum location of retentive elements of the framework. The stiffness of chromium cobalt alloys can be overcome by including wrought wire retentive elements in the framework. The chromium cobalt alloy have a lower density weight than gold alloy in comparable sections and are therefore about one half as heavy as the gold alloy. Weight of the alloy is most instances and is not a valid in the selection of one metal over another, because after placement of a partial denture, the patient seldom notices the weight of the restoration. The comparable lightness of the chromium cobalt alloys, however, is an advantage when full bilateral coverage is indicated for the bilateral distal extension partial denture. The hardness of the chromium cobalt alloy presents a disadvantages when a component of the framework, such as rest, is opposed by a natural tooth or by one that has been restored. Okay, now the wrought wire selection and quality control. The wrought wire direct retainer may be attached to the restoration by embedding a portion of the wire in a resin denture base, by soldering a fabricated framework, or by casting the framework to a wire embedded in the wax battery. The physical mechanical properties of available wrought wires are most important consideration when a proper wire for the desired method of attachment is selected. These properties include yield strength or proportional limit, percentage elongation, tensile strength, and fusion temperature. Okay, now the improper laboratory procedure can diminish certain desired physical properties of the wrought structure, rendering it relatively useless for its intended purpose. Now, for example, when wrought wire is heated, such as in a cast to or soldered in case of soldering procedure, its physical properties and microstructure may be considerably altered depending on temperature, heating time, and the cooling operation. When wrought wire is soldered to framework by electrical soldering, it is subjected to a momentary temperature of about 1500 Fahrenheit degree, of course depending on the solder used. If the heat is high enough and long enough, the fibrous microstructure of the wrought wire disappears and it's replaced by grain or crystalline microstructure. The process is known as recrystallization or grain growth and is um, a most undesirable occurrence in wrought wire retainer arms. To avoid such a recrystallization of wrought wire, a high fusion wire should be selected. Temperature must be rigidity controlled when using either the cast or the soldering method. We will discuss that later on in one of our lectures about dealing with the metal in terms of soldering and welding, of course. But we should put in our minds these points. Now, to compare between the cobalt chromium and the gold alloy in terms of mechanical properties, the cobalt chromium have lower yield strength, while the gold alloy high yield strength, greater than the chromium cobalt. What's that mean? The lower yield strength, that means stiff material. The high yield strength, that means flexible material. Okay? Now, the chromium have high modulus of elasticity, also related to the hardness and the stiffness, while the gold alloy approximate one half of that of the cobalt chromium or chromium cobalt alloy. If we took the same cross section or the size of a sample, for example, chromium have less flexible and high stiffness, while the gold alloy have great flexibility and less stiffness. The chromium cobalt alloy have lower density and the gold alloy have high density. The chromium cobalt alloy low material cost, while the gold alloy more expensive. Now, what I would like you to prepare for next week, dear students, to prepare the quiz, which is compare between the gold and chromium cobalt removable denture alloys in terms of mechanical properties. So you will have a table with the gold alloy and chromium cobalt alloy used for removable denture, and to compare between the mechanical properties of them. I would like to say thank you for you. Looking forward to discuss the next lecture topic. Take care and goodbye.